All right, this is a challenge in a real-world connection problem on inverse functions. I encourage you to pause this video, try these on your own, and then check back in and see how you did. So let's do the left-hand one first. And the question is, are the inverses of the following functions also functions? Use Desmos if you like. Let's definitely use Desmos for this. And what I want to remind you of is that a function's inverse will also be a function if the original function also passed the horizontal line test. So to be clear, looking at the picture I have for you right down here, a function needs to pass the horizontal line test in order for its inverse to also be a function. All functions need to pass the vertical line test, right? But if a function fails the horizontal line test, then its inverse will fail the vertical line test. So here's an example of a function that is a function but fails the horizontal line test. It crosses a horizontal line, intersects that function 3 times. So this function's inverse would not be a function, it would simply be a relation. Okay. Another way to think about this is a function needs to be one-to-one in order for its inverse to also be a function. A one-to-one function simply means it passes the vertical and the horizontal line tests. Okay, I'll shut up about that. We can move on. Are the inverses of the following functions also functions? So basically what we're looking at are functions with odd exponents, and then secondly, functions with even exponents. Okay, and we're just going to look at these basic functions right now where they're just single terms, x to an odd or x to an even exponent. So let's think about the odd exponents first. We'll do that over in Desmos. And I have this set up where I have a slider that is set to give us only odd exponents. So in purple, I have the original function, which is overlapping now and you can't see it because the inverse is on top of it. In red, I have the inverse function, and all I did was swap x and y. I didn't take the time to solve for y. Desmos can handle graphing something without y being solved for. So let's, we have a line right now, but let's change some of the exponents. And first off, just be looking as I move the slider, looking at the purple original function. It's always a function, right? Because it always passes the vertical line test. But does it additionally pass the horizontal line test? It looks like it does. So it looks like it's always a one-to-one function. We could actually zoom in a little bit or a lot. We might not be able to see it, but where it looks like that purple line gets perfectly horizontal, it actually never is perfectly horizontal. There always has a little bit of a slope to it. Okay. And so since our purple function always passes the horizontal line test, it means our red inverse is always a function. Okay, so the red inverse will always pass the vertical line test, making it a function. Okay, let's change our slider. So actually, going back to our notes, it looks like the answer to this question is yes, inverse is a function. And where it's odd, the answer is also yes, inverse, f inverse of x. And actually here I'm calling it h of x, so let me be clear with my notation. H inverse of x is a function. Okay, we can go back to Desmos and explore with some even functions here. I'm going to change my slider and have it start at 2 and go up to an even number. And now you look at purple real quick. Purple looks like it's always a function. It always passes the vertical line test, no matter what the slider's doing, no matter how big our exponent is. But it looks like no matter what, it fails the horizontal line test, meaning that it has an inverse, but its inverse is not a function. So looking at the red kind of sideways graph, that relation there always seems to fail the vertical line test, meaning it's never a function. Okay? So let's go ahead and summarize that back in our notes. So this is not a function. Actually, let me be clear. The original thing is a function, but g inverse of x is not a function. And I inverse of x is also not a function. Okay, hopefully that clarified things a little bit about vertical and horizontal lines tests. Next one is a little bit quicker and easier. An object falling under the effect of Earth's gravity follows the following relationship between distance and time. D equals 4.9 t squared. Okay, so in other words, you can think of D as a function of time. You can think about it like this. Okay, we're feeding it a time value, and our function D spits out a distance that the object has fallen. You're, however, programming a computer to calculate the time required for objects of different heights to fall. So we want to be able to figure or feed our function or feed this computer a height and have it spit out a time. Okay, so all we're going to do is swap x and y, or in this case, actually no, we're not going to do that. All we need to do is solve for t. Okay, so we are going to undo what's being done to this function right now. So let's solve for t. So we can divide both sides by 4.9. And we get d over 4.9 equals t squared. And then lastly, we can square root both sides. Okay, and that's going to give us t is equal to the square root of d over 4.9. That's really all it is. We just needed to isolate for the other variable, for t. So now we have t as a function of distance is the square root of distance over 4.9. Nice, we did it. It's a good place to stop.